Hello everyone. Today I will be presenting the Smart Product Recommender, an AI-powered tool we implemented at AST. AST stands for Alphametic Services and Technologies. We are a company or a Lebanese-based company working for the Lebanese market and abroad. This tool that I will be presenting today is an AI-based tool based on OpenAI's text embedding model, text embedding ADA002. So this is the one. We chose this text model or this model because it's highly cost effective and it is efficient for general purpose embedding tasks like similarity searches. Our main goal here is to achieve similarity. This model allows us to work with regular text data and generate vector representations that can be compared mathematically. I will present after some time the cosine distance logic and why we need this mathematical calculation in the logic. So this model, the text embedding ADA002, provides 1536 dimensional embeddings. Well, this is actually the output vector, which comes out of the OpenAI API, the embedding service, and it is 1536 length. This embedding captured the semantic meaning of the input text. So after some time you will see that it's not like only like matching one-to-one, but it's also matching based on the context, the semantic context of the text. Why this model also? Because, as I said, cost effective, which means with a cost of approximately 0.0001 per 1000 tokens. We are talking about 1 million tokens, cost around 1 cent. It is one of the most affordable solutions for building production grade recommender system. So as I said, these embeddings are used for comparing text similarity, which brings us to the core idea behind this recommendation tool, which is matching users and products. For example, suggesting products to users based on the user's interests and social activity or social media activity. So let's dive a bit deeper in the solution and the project structure. So here, if I go to Visual Studio, the solution is built on .NET 8. It's a it's a very normal C# .NET API backend, and the front end is a React application. And to store the user and product vectors, we are using the Qdrant database, which is a high performance vector embedding system running locally in Docker desktop here. As I said, the application is a typical C# .NET application containing controllers, having services, product service, user service, embedding service. The embedding service is responsible for communicating with the OpenAI API to obtain embeddings, as I mentioned earlier, for both users and the products. I will show you now in the application, for example, the users here. These are the users that they are coming from the Qdrant database. Here, if I check collections, I have users and the products. And in the users here, I have, for example, 5 points. I was too quick actually here, 5 points. And if we go to the application here, I see 5 records which represent or reflect actually the 5 points from the Qdrant database. So if I click here on show user details, I see the user details, and then I can click here show vector points, and these are actually the vectors that they are related to this user and they are saved in the Qdrant database. How do we construct these vectors? These vectors are being constructed or they are being constructed as a concatenation for the user, as a concatenation of country, interest, and social media activity. Just concatenating these in a text and then sending them to the embedding service and getting the vector back from the OpenAI API. The same concept applies to the product. The construct here is tag and description. Well, we are not mentioning it here, but it is tags and descriptions. And if I click here, show vectors, we can see the vector of this product. So, for example, if I go here to the users back and I click here for the user Alfred Sandro. Alfred Sandro is interested in gaming, RGB lighting, mechanical keyboards, social media activity. He liked gamers.de, and I say show matching products. I see that this guy has as matching product RGB mechanical keyboard as the first suggested product with the highest score. Then we have the manual espresso machine and the smart LED. And here you see something like plotting. I will come after some time to this topic, plotting, which will plot actually the matching for the user on a graph. So we see it also on a graph, or we can easily identify which product is the most near one to the user. So, as I said, in Qdrant we apply similarity search, which means we send to Qdrant the two vectors or one vector from the user, and we say get me all the products that they are similar to this vector. What does this mean? This means that we apply similarity search, which is empowered by or powered by cosine similarity. What is cosine similarity? Cosine similarity measures the cosine of the angle between two vectors in high dimensional space. So it tells us how aligned are two texts based on their direction, not the length, but the direction. So if they are both in specific directions, it will tell us how aligned are these two lines in a specific direction. Why this cosine similarity is useful? It's a scale invariant, meaning two vectors with the same direction but different lengths will still have a similarity score of 1. As I said, it's not about the magnitude, it's more about the direction. So score 1 means it's a perfect match. It helps identify semantic similarity based on context, even if the word choices are different. As I said, it is a semantic search or semantic similarity search context. The closer the cosine similarity to 1, if you see here, the closer to 1, the more semantically related the user and the product texts are. So, as I said here, well, it is a length of 1536 is the vector length. How can I plot it here? There should be a way that I plot it here, otherwise with 1536 I can't plot it here. So we implemented something like a reducer. This is a utility which reduces the 1536 vector to 2D dimension, so X and Y. And based on this guy here, for example, Alfred Sandro, we can see that the most near product to Alfred Sandro is the RGB mechanical keyboard, and you see here it is here, just like the nearest one to this user. If I go to other users, for example here, Mark Wayne, then you will see here that it's hanging a little bit. Let me refresh. So you see here that this guy is interested in coffee, minimalist design, kitchen gadgets, social media activity, for example, espresso machines. He liked home barista DE. And if you see the matching products are, well, it makes sense that the manual espresso machine is the most matching product, and with a score of 0.89. And if we check here the user, Mark Twain, and of course the nearest product should be actually the espresso machine, otherwise the logic will be